This morning I wanted to cover a concept called test-driven development. Now this is a point of, let's put it this way, there are kind of like religious holy wars inside of the world of programming between like, oh, I really like this text editor called Vim, or I really like this text editor called Emacs. Like there's kind of like a whole, it's kind of like a for fun type of thing, but it's a point of contention for a lot of different people. Test-driven development, on the other hand, is slightly a point of contention for people. So it's TDD. You're going to hear this quite often. Everyone's going to talk about TDD pretty soon. And it stands for test-driven development. It's the concept where I'm going to write the tests with desired results first before I write the code. Up to this point, we've just been writing the code and then writing some tests, maybe just to make it true and false. But fairly soon, we're going to just be writing tests first. Well, sorry, today we're going to be writing our tests first and then writing the code to make that kind of stuff pass. Now, people are going to argue one way or the other. Most folks, let's put it this way, most people, and the correct answer that you should give to your employers and on interviews is, I love test-driven development and I write my tests first 100% of the time. All the code that I write is fully tested, et cetera, et cetera. That is the correct answer 100% of the time when it comes to interviews and first few jobs and things like that. Whether or not that actually gets done is something different. So can anyone think of why writing your tests first before you even start writing any code is useful?
So you have a goal?
You have a goal, yeah. You have like a blueprint. You have an idea of where you want to go. It's kind of like getting into a car without any sort of directions and just having like an end destination, but no idea of how to get there. We can do that now because we have GPS, but imagine the days where we had to print out Yahoo or MapQuest and things like that. And it was just like, I just know I need to get to Las Vegas. I'm in New York City. Let's just drive. That's not really like a good way to get there. So you have to figure out how many miles am I going to go on this particular highway? When do I need to stop and things like that. It's like having a blueprint going in front of you. Oftentimes also when you're talking about, oftentimes when you are thinking about like the code that you're about to write, there's a lot of pitfalls about like, I'm not really sure what I'm going to do, so I'm just going to jump into it. So that's why I always ask, what's the input and what's the output going to be? When you do test-driven development, it's going to come out no matter what. You have to be able to write those tests and know where your program's going to go. And it helps you think through potential pitfalls and bugs before it happens. Sean?
I was going to say, like, I think it's really important because of all the edge cases that will probably inevitably come up with what you're doing to think through all those things and write those tests.
Yeah.
Right?
Yeah, that's not incorrect. Yeah, so that probably won't happen right now with just algorithms. But what Sean's talking about with edge cases is like those one-off, like 1 out of 100 times this thing could potentially happen, and we need to be able to account for those potential things. Probably won't happen with your algorithms, but like when you're writing like banking software or loan software, it's like, what if this person clicks this button first and then clicks this and they click this by accident, and then they can magically hack the site or something like that. So you have to account for every possible scenario. And if you can think that all out in test form, then you can write your code to protect yourself against that. Most of the top tech companies in Chicago follow this type of process. So we're talking things like, I know Braintree for one does it, DevMind is another one, and Pivotal Labs. So I actually want to ask, are there any things that you've heard about tech companies that you want me to verify are true or not true? I know there's some sort of like, everyone's like, oh, they have massage chairs in massage therapists at Google or something like that, or they have a cafeteria that they don't need to pay for, or they have coffee shops and things like that. I want to say, does anybody have any questions about any tech company? Yeah, I will say all the things I just said are true.
They are?
I've seen it in real life.
Oh,
okay.
That's my question.
Yeah.
That's my question.
Yeah.
I imagine it's like Uli from Silicon Valley.
I haven't watched Silicon Valley, but I don't have HBO. Yeah. But yes, they do have massage therapists once or twice a week, and you just sign up. They have a cafeteria on site with a full kitchen and the catering company, so you can go in for breakfast, lunch, and dinner. You can just you can also like take some to-go containers and just pack your dinner, so you never have to like actually pay for food. They do have a coffee shop inside the Google Chicago office, which I humorously took out my wallet, and they told me to not to put it away, that this was Google, and then I didn't need to pay for it. So it's incredible what some companies are willing to do.
What were you doing at Google? Were you working there?
No, I was so Code Platoon sometimes has graduations at Google, depending on how large the cohort is and if we just can. With the size of this one, I don't know where we're going to be, but we've been at Google, Amazon, Google, and Google. So 3 out of the 4 graduations that we've been outside of like Code Platoon area, we've been at Google. So it's been pretty nice. Hopefully we can push for that. Amazon's also fairly nice. There's a bunch of other nice companies as well. It's not just Google, but Google does have the best stuff. So there are a few companies here in Chicago that I kind of wanted to point out just because they do software, air quotes, correctly. They do, pair programming, they do test-driven development, they do like all the things really well with, retros on Fridays and daily stand-ups and things like that. One of them is Braintree Payments. Braintree was purchased by PayPal a few years back, and they just do payment processing. That's all they do. They just do payment processing. So if you want to get paid as like a vendor, if you're selling something and you're allowing people to swipe credit cards on your iPad and things like that, they're the people who handle this. They are located at the Merchandise Mart, and I think one of our TAs named Ryan is there. Do we have a TA named Ryan?
Yeah, Ryan Boniak.
Yeah, he works there. And they do have, I think they have catered lunch every day, and they have scooters in the office, and like basically everything that you expect. DevMind is a consultancy. Do people know the difference between a like a software consultancy and a enterprise company? Okay. Do you have an idea?
I do, but okay.
Okay. So a web consultancy is basically let's just click on this. They have a pretty nice website. It's basically, I have an idea that I want to build out. Like I have an idea for a business, or like I already have some seed funding and I want to build out my website and my web app. But I don't have a software team. So I'm going to hire a company like this. They have maybe 25 engineers on staff, and 3 people will work exclusively on your website for a rate of, $125, $150 an hour. So they will work on your site and they'll build it for you. They'll charge you $150 per developer per hour, and then they'll build you your thing within X number of months. You as the developer, you probably only see like $50 of that, $50 to $75, maybe $100 if you're really senior, but that's generally how it works. So that's a software consultancy, and they do all this type of stuff. And I know quite a few people who work here. It's one of the top shops here in Chicago, and they have one in San Francisco and also in London. And then you got something like Pivotal Labs. So Pivotal is interesting. They just IPO'd. I think they were worth $3 billion last year or something like that. And they just IPO'd less than 2 months ago. So they are both a web consultancy, and they are also an enterprise. So enterprise is like Chase or One Main Financial or Groupon or something like that. It's a big company that gives out a variety of products. Like that's what they do. And you as a developer, your job is just to maintain those products and to add new business lines and help out other departments inside of your company. A web consultancy, everything is brand new. It's most of the time, it's like, I have this idea, I just want to build it. How can we make this happen? You get to decide the technology stack that you're using. You get to decide, you get to decide basically everything. So does any one of those two stand more out to you? It's like each person's a little bit different. I personally am not a web consultancy person because I don't like, it's kind of fun to build new things from scratch, but if you break it, like you broke someone's dreams, so it's too much pressure for me. I know it's not just me, but I just feel bad if it doesn't turn out well.
I like the web consultancy.
Yeah.
I wouldn't want to do like any front end stuff.
Okay, you don't know that yet. You've just been doing algorithms so far, but you don't know if you like the front end or the back end better.
I'm not that imaginative.
Well, front end developers actually don't draw this stuff out. Those are designers. Your job is just to write the code to make the designers. Well, let's just go over real quick, and then I promise we'll get back into actual coding. So there's back end engineers. People basically, when I fill out a form and I press submit, all of that code, all the things that you entered need to go somewhere inside of a database. Your primary job is basically get data from the database and give it to the front end. That's basically what you do. So somebody submits a form, you take all their data, you put inside the database. Somebody asks for some sort of data, you grab all the data out of the database and present it to somebody else. Front-end engineers are the people who so there's designers. A designer clearly designed this whole thing, like, oh, I know I want this particular shape and I want this type of font and I want these types of margins and things like that to make it look really nice. Those are designers. The people who do the front-end code are called front-end engineers. They're the people who say, all right, I see your idea. It's called a sketch file. It's just like they drew it out, basically. I can make this happen in real life. That's basically it. So each person does something a little bit different.
There are unicorns.
There are unicorns. They're called full stack engineers. And full stack engineers means that you know front end, back end, like database, how to deploy this to the web. So this doesn't just magically appear in the internet. Like someone has to make that happen. Those are full stack engineers. And if you work at a small startup of 2 to 3 people and they say, we need a full stack engineer, they're basically saying, I need one person who could do everything for the low price of like a front-end engineer or something like that. It's interesting stuff.
I get a bigger company that be just like supervisors, like look at all the pieces. Right?
Yeah, pretty much. But they're not, supervisors generally don't write most of the code. It's actually mostly junior and mid-level developers. Senior developers are just there to make sure that the code that you write doesn't blow up everything. So we have Pivotal Labs, we have Braintree, we have DevMind. There's 2 themes that I saw when I saw the companies that do mostly test-driven development. First, like Pivotal is a $2 or $3 billion company that just IPO'd. They've got a lot of money. Second, Braintree was bought out by PayPal. They got a lot of money. DevMind, it's a small web consultancy, probably does $20 million of revenue in a year, but they can charge their time out to other people. So it's either companies that A, don't have a lot of huge pressing deadlines, or 2, can charge out this their time to other people. That's generally when people use test-driven development because it's expensive. You have to write everything out, all the tests out first. It's a much slower way of writing software, and that comes at a cost. That being said, your software is 9 times out of 10 going to be much more sustainable, much more easily updated and things like that. Let's take a look at what we're going to do. TDD, yeah, go ahead.
Are there people that just write the tests and then give it to somebody else to write the code?
Yes, there are people who do that. So the question was, are there people who just write tests and then give it other people time to code it? And yes, there are. That's your QA team. But there are different levels of tests, which we won't get to right now. But what we're writing right now are unit tests, just making sure the code works. The QA people are going to write the tests that say, does your code work within the context of this giant app? And then if it breaks, I'm going to send it back to you. But yeah, there is a QA team on most people's teams. But you have to reliably say, I am the QA team. You should be responsible for your code. It's not like I'm the rock star. I can come in, just write my code. Someone else writes the test for me. Like that, you have to write your own tests. So when we're doing TDD, we're going to follow this thing called red, green, refactor, RGR. So red is basically I'm going to write a test, and before I write any sort of code, I'm just going to watch it fail. I'm just going to write the test, don't write any code, run the tests, and watch it fail. It's going to turn red. Then I'm going to write just enough code to make the test pass. So I'm going to write the code that I actually expected to write, and I'm just going to run the test. If it passes the test, it's going to turn green, and then only after it turns green will I refactor it. I'm going to make it better. I could write 1,000 lines of code and make it pass, and I'm going to maybe condense it down to 200 lines of code or something like that. So I wanted to start off with a very, very simple idea. I'll just download this for now. I just wanted to start off with a very, very simple algorithm, which is the FizzBuzz algorithm. Are people familiar with this? Sure. So I remember doing it with Michael at Deloitte, but it's basically an algorithm that they say 99.7% of software engineering candidates cannot actually pass, which I find personally difficult to believe. But since the pool is so vastly large, I can see why that would be the case. Let's take a look at the prompt. There it is. Oh, nope, it's right here. All right. Oh, sorry, 99.5% of programming candidates. If you can't read this, I'll read it real quick. It says, write a program that prints the numbers from 1 to 100. But for multiples of 3, print fizz instead of the number. And for the multiples of 5, print buzz. For the numbers which are both multiples of 3 and 5, print fizz buzz. So it's basically list all the numbers between 1 to 100. So it should be 1, 2, fizz, 4, buzz, 6, 7, 8, fizz. Like it basically, everything that's evenly divisible by 3 is going to replace it with fizz. Everything evenly divisible by 5 will be replaced with buzz. And then everything evenly divided by 3 and 5 will be replaced with fizz buzz. So we're going to do that really quickly. Let's take a look right over here. So I've got the code here on the left-hand side, and I got the spec file here on the right. We're going to be using a library called R-Spec. So in order to bring that into my code base, I'm just going to do, into my computer, I'm just going to do gem install R-Spec. There's links to it today so you can read a little bit more about it, but essentially it's just a way that we write tests. Up to this point, we've just kind of been saying like print some method 2 is equal to 5 or something like that. And then this just prints out a bunch of true and false statements, right? But it's not terribly useful because you have to like count which line the false was on and find that test and then figure out what was broken. We're going to be using something called R-Spec here. It looks a little something like this, and it looks very, very daunting to start with, but that's okay. I'm going to get rid of a bunch of stuff. I see that hand. Give me 1 second. Go ahead.
For our first challenge yesterday, I couldn't get the spec file to work, and I think it's because I didn't have R-Spec and there's R-Spec.
Yep, probably. All right, so first line here says require relative. So as everyone knows so far, require is to bring in an external library. So if I have R-Spec or pry or something like that, I want to bring that into this file. That's what I'm going to be doing here. But require relative requires another file. So you can kind of see I've got, where is this? Reveal in sidebar, reveal in Finder. So I've got, let me just create a quick folder, PDD, move these two inside. All right, so inside of this folder called TDD, I got FizzBuzz and FizzBuzz spec. I'm going to require another file because I'm going to be calling the code inside of the actual code file inside of here. So I'm going to require relative of another file called FizzBuzz. I don't need to do .rb because since this is a Ruby file to begin with, they know that this is what it's going to be. So you can kind of see there's a bunch of describe, let, describe, and things like that. It's kind of difficult to understand, but essentially what it is I'm kind of spacing out the code to know exactly what I'm talking about. As of right now, we're only going to have one test. So I'm going to describe FizzBuzz. And then we have this giant it block. So when we're writing R-Spec, basically what we're going to be doing is we're going to be testing every single method that we write. So I do describe, and then in single quotes, hashtag the name of the method that we're testing. Underneath here, then we have an it block. The it block at this particular point is human readable code. Up to this point, we've just been printing out a bunch of true and falses. If the third thing is broken, then you have to find the third test and figure it out. This one will tell you exactly what went wrong. So this is something that for us to read, what is a good test for us to do before we start writing this code for FizzBuzz? So again, we have the rules were, actually let me just grab the rules. So I've got the rules here. Let's think of a test that we would want to make sure works before we can get anywhere.
Accepts a number.
Accepts a number. Well, that's not the purpose of the it says we're going to print out 1 to 100 no matter what. So what's your input and what's your output?
Well, you could also say like it is a method or function.
You could. That would be very strict TDD, but I hate that. I don't want to do that. Like,
Prints fizz for multiples of 3.
sure, it prints fizz for multiples of 3. All right, so I know that's going to be one test that I need to write later. It prints probably buzz for multiples of 5. And it prints fizzbuzz for multiples of 3 and 5.
I'm just saying that we're just writing messages for ourselves.
These messages are all for ourselves. Yeah. The code will run on its own. The computer doesn't need it, but this is for us to troubleshoot.
Well, I mean, within how we execute on those, we have to be super specific, right? Because 3 and 5 can't fit at the same time.
I do not follow that statement. Okay. All right. So what's your input and what's your output?
Input is numbers. Output is 1 through is 4 buzz or above.
Nope. So it's good that we're doing this. Let's read carefully. It says write a program that prints numbers from 1 to 100. So do we need anything coming in?
No.
Probably not. What is the output? So it says it prints out the numbers from 1 to 100. So what is your output going to be?
Numbers 1 through 100.
1 through 100. What data structure do you think you would want for that? You can do a string. You can do what else? An array. It's your choice. I don't care.
I would say yeah.
Let's do an array. It returns an array of numbers of 100 of. It returns an array of 100 things. Not a very descriptive test, but it's something, right? It returns like 100 things. It's either going to be a number or it's going to be a string. Right. So I think we've got a pretty decent start. What we're going to do now is we're actually going to start writing the test. So I'm going to expect when I run fizzbuzz, and I find maybe the output's going to be 0. How do I write the test to basically say like every single time a 3, like anything evenly divisible by 3 shows up, that it's replaced with fizz and the number is not there? Well, we can hard code some things too. Actually, let me just do a really easy test. I'll move this one up here. So it returns an array of 100 things. Expect fizzbuzz dot class to equal array, and then at the same time we're just going to do expect fizzbuzz dot length to equal 100. So when I run the algorithm fizzbuzz, the output, I expect the class of the output to be an array, and I expect that array to have 100 things inside of there. That's what I've got here. All right. So this is fairly simple. And then we'll just jump down to here. So if I have like 100 things, so I think it should be like 1, 2, fizz, 4, buzz, 6. Wait, is this 6? Is this fizz? Yeah, it's fizz. 7, 8, fizz. 10, buzz. 11. I'm just going to go up to 15 here. How's that? 12 is fizz. 13 is 13. 14 is 14. And 3 and 5 both go into 15, so it's fizz buzz. So these are the first 15 values of the output. So maybe I can just do a quick hard coding. So I can do the 0, 1, 2. So I expect the second thing to equal fizz. Maybe I expect the third, fourth thing to also equal fizz, and so on and so forth. Similarly here, 0, 1, 2, 3, 4. Maybe I expect the fourth thing to equal buzz. Wait, 0, 1, 2, 3, 4, 5. This is 5, my bad. And I expect the 14th thing to be FizzBuzz. How does this look? It's kind of like a blueprint of where we're going. So I wrote again, require relative says I'm going to be using the code in some other file. Specifically, I'm going to be using this FizzBuzz method that does not exist here on this file. Like there's nowhere that says def FizzBuzz. So because it's not here on this particular file, I'm going to require relative and bring in another file. And then I have described this one particular method, and then I have a bunch of it blocks. These it blocks are human readable code for us, just so we know what's going on. So the first things first, we're just going to return an array of 100 things. Like we know what our input is, and we know what our output is. And then we're just going to check, does our algorithm do exactly what we expect? Is every single multiple of 3 going to be replaced with fizz? Is every single 5 going to be replaced with buzz? 3 and 5, is it going to be replaced with FizzBuzz? I'm just doing the first 15. There's probably a better test, but just for the time's sake, I'm just going to keep it like this. Yep.
Inside the square brackets, in that it block, expect FizzBuzz 2. Expect what is that number represent?
So again, we said that it when I call FizzBuzz, it returns an array of 100 things. So FizzBuzz returns me, a square bracket of array of 100 things. So the first 15 things look a little something like this. So since FizzBuzz returns me this array here on line 9, the second thing, 0, 1, 2, should be fizz. 3, 4, 5, that should also be fizz. Everything with a multiple of 5.
Got it.
Got it?
Understand now.
Cool. Yep.
And for the last one, multiples of 3 and 5, is that really just 15?
Well, let's think through it, right? So anything that's like 9 is evenly divisible by 3, right? 10 is evenly divisible by 5. Anything that's evenly divisible by 3 and 5 is divisible by 15.
Okay.
Yep. So we've written the test. We did that first thing. We're going to run it. So let's take a look at everything. We're just going to, I'm in the wrong folder. Okay, I'm going to run R-Spec instead of Ruby, FizzBuzz spec.rb. When I run this, it gives me a bunch of red. Like there's a bunch of stuff that's just broken. So first things first, we can read one by one, or like we can make all of these, we can run all these tests all at once, or we can run one at a time. It's your call. If you want to run them all at once, you just do R-Spec FizzBuzz spec.rb, or you can add this --fail-fast, and this will blow up at the very first time that something blew up, and then stop running so that you don't have to see a wall of red. So we're going to do red, green, refactor. This first thing says on the spec number 5, on line 5, there's an undefined local variable or method FizzBuzz. That makes sense? We don't actually have any code. So def FizzBuzz, and we're done. So it's like red, green, refactor, like very, very slowly. Like this is like strict TDD. So again, my first error message says that there was an undefined local variable or method FizzBuzz. When I run it one more time, I get something different. So this goes away. What I got was, I expected there to be an array, but instead I got a nil class. Okay, not an issue. I'm just going to return you an array for now, and then we'll make the last thing blow up. I expected the length of that array to give me 100, but instead I got 0. So it's kind of like I'm going to write all the tests, run it one by one, and we're just going to make that last thing pass. Let's write this code really quickly. So we're going to print out all the numbers from 1 to 100. So I think we can just do output equals 1 to 100. I'm going to do return output somehow. And I know I want to destructively change the numbers inside of output. again, output just looks like this for right now, 1 through 100. And I want to destructively change 3, 5, 9, 12, and things like that. So what is the destructive method to change an array?
The bang.
Yeah, but which one? But which method?
Just replace.
What's that?
Or we do it looking for replace.
It's not replace. So it's gonna. I'm just gonna do it real quick. It's output.map bang. So map is like is essentially an each loop. So I'm iterating over every single thing. But map will destructively change things based off what you do to it. I'm gonna map do number. And then basically, basically we have this. Actually, we don't even need that. We have the test written over here. So we know that we're gonna get 100 things in the end because we started with 100 things. So for multiples of 3, I'm gonna replace it with buzz. So what's the condition that I have to write for that?
Yeah.
Number. Yep.
3.
Mhm.
Okay. If number modulo 5 is equal to 0, number is plus, else, not number, or no, I'm sorry, else if, I'm sorry, we gotta do the else if number modulo 15 is equal to 0, then number is equal to this buzz, else number.
Okay. So we've accounted for everything. If a number is evenly divisible by 3, we're going to replace it with fizz. Evenly divisible by 5 and 15, and then we have every other number. Does anybody see an issue with this, or should I just start running the test?
You got only one Z in this buzz.
Anybody else see something else that's not a typo? Sean?
Well, I'm just logically, shouldn't you start from the highest and go to the lowest?
You should start with the highest and go to the lowest. Why did you say that?
Because it'll execute like the fizz on things that would otherwise be 15.
Yep.
So on and so forth.
Yep, pretty much. Yeah.
Just going or like order of operation.
So we know that 15 mod 15 gives me 0, right? 15 is evenly divisible into 15. If I pass in the number 15 with the currently written like this, it's going to hit the first one and replace 15 with fizz, because 15 mod 3 is 0. So it's like I met this condition, I don't need to do anything else. So I need to have the most restrictive condition all the way at the top. And I think that's it. It doesn't matter if it's 3 or 5 first, because 3 and 5 are not evenly divisible into each other. So I think we're good. So we wrote the code. So red, everything was red at first. Now we made it green, hopefully. We'll see what happens. Just like that, we have all green tests in one swoop. So it feels pretty good. So again, we're going to write all the tests first, and when it's broken, like when it's broken, this basically what's going to happen is all of that it block code that you wrote over here is going to tell you exactly which test failed, and then you can find it really quickly, and then you know the context right away. We like even at a small mid-sized company like OneMain, we had a test suite that took 45 minutes to run, and there's millions of lines of code inside of there. When you break one thing, you have to figure out exactly where it is, and imagine if you had to go through a whole list of true and falses, and then you have to find this line is broken. All right, then I have to go back to that test and figure out what's going on. By having the it block here, it helps you with just context in general. Yeah, Marvin.
Do we have to use that testing suite? Like, could I use mini test instead, or
no? We're gonna use R-Spec. Yeah, mini test is. So there's nobody uses mini test.
Okay.
Yeah. And because R-Spec translates pretty quickly into other testing frameworks as well. So the equivalent of this in JavaScript is Mocha-Chai, and it looks almost identical. There's expect blocks, there's it blocks, there's describe blocks. So, cool. One more example, and then I'll let you get to it, is called guessing game. This is the one that nobody got to last week. Now, I'm not even going to read the README. I just expect the test to be so well defined and so well written that I can figure out exactly what this game is supposed to do. So there's a lot more tests here, and it looks like we have, all right, line 1, require relative of guessing game. So it seems like I'm going to be using code inside of guessing game inside of this particular file. So it looks like all of these describe blocks that we had with these hashtags to describe methods is all nested within the class called guessing game. So I'm testing the entire guessing game, and all of these tests are part of that giant class. There's an initialize one, there's a guess method, there's a solved method, and I think those are the only 3 things that we need. So this let game, so you can't just, I wish you could just do this, but it's just game equals guessing game.new with 10 is not a way that you can reuse variables inside of R-Spec. You have to do this let game equal this guessing game thing. It's just syntax. It's unfortunate, but that's just how it runs. All right, so describe initialize. It expects a single argument. So I'm just going to change directories real quickly and go into guessing game. And because the specs are really well written, I'm just going to do guessing game spec -- fail - fast and just make each one pass one by one. And eventually, I'm pretty sure I'll get everything to be done. So it looks like guessing game expects a single argument. You can see that this expects a single argument is this if block right here, so that when I read it, I know exactly what's wrong. All right, it looks like I have a guessing game. I need an initialize method, and it takes in one single argument. I'll just say maybe it's a number. Run the specs. You can see that before it was failing on the first one, but this little green dot says I have 2 examples, 1 failure, rather than 1 example, 1 failure. So I just made the first test pass. It looks like it's going to take in a number. That's what it's passing in over here. I'm going to do @number equal number, because I'm pretty sure within this entire class, I'm going to need to basically say the number that you pass in, you're going to need to use over and over. So I'm assigning an instance variable to it. I'm immediately going to make it an adder reader just to start. I don't want to make it an adder accessor to begin with. I just want to make it a reader.
And you know that it was a class because it had .new on there.
Mm-hmm. Anything with .new on it is a class. So let's just make sure our test pass still so far. So we have 2 examples, 1 failure. And we read the next test. It says, the guess method is defined. Is there a method called guess? No, there's not. So I'm just going to do def guess. I have 2 examples, 1 failure, and I'm going to continue down the road. Now we have 3 examples, 1 failure, so we just passed the previous test. It's kind of a tedious, laborious process, but because these tests are written here, I know exactly which direction I need to go. So it looks like I passed this test. It expects a single argument. So looks like guess needs to take in an argument. Three examples, 1 failure. I'm at 4 examples and 1 failure. So it returns high when the guess is too high. So I'm guessing it's basically a user will give you a number, and you're going to compare it against the number that's the winner. So how do I do that? So again, this is the user's guess. You're comparing it against the original number. And if it's high, then I'll return high. If it's low, then I'll return low.
So if at or number, because we said it was an at reader, so we just make if number is greater than user guess, then print high. Oh, too high.
Yeah, I think specifically they're looking for this high over here. So I'm just going to return the high. Actually, no, it's the other way around, sorry. If the user guess is greater than, again, we're just doing one test at a time for this one. If the user's guess is greater than the answer, I'm going to return high out to the screen. So we have 4 examples, 1 failure. We still have 4 examples, 1 failure. So it looks like there's an undefined local variable or method called answer. What the heck? Oh, whoops. Whoops. Stupid. And we got 5 examples, 1 failure, and we're just going to continue down the line. So this one breaks if the guess is lower. So if the guess is greater than the number, then I'm going to return high. Else if the user guess is less than the number, I'm going to return low. So I'm on this particular test at this point. 6 examples, 1 failure. You can kind of see I'm just going straight down the line. Because the tests are pretty well written, I have a very clear idea of where I'm going. It's also a very simple game. But else. So if it's greater than the number, I return high. If it's lower than the number, then I return low. Else is basically every other thing was just is it equal? I'm going to return correct.
What does that mean with the colon in front and then?
This is just like, this is called a symbol. I could have just made, you can change the test if you want to just be like a string of high and a string of low, but they decided to go with a symbol version of it. So we had 6 examples, 1 failure. If this goes well, I'll see 7 examples and 1 failure. All right. Next, we say, next it says, when the game is solved, when the correct guess is made, basically, do you have a method called solved? Okay, it's fairly simple. Def solved. All right. I expected solved to initially have been false, but it was nil. So because I wrote the test ahead of time, can you guess what I need to do here?
So you're adding an argument
I could.
to solve.
You mean like this?
No. Commit.
So I'm here on this
we can
test.
put-
Yeah.
We can just have solve. Make another instance for it. Get it, just say solve. And then have that equal to false. And then we change it to true when user dot guess, or I'm sorry, guess when that returns correct.
Cool. So you said I don't need to pass in anything to guessing game because by default you haven't solved the game. So I can just put it as an initialize instance variable over here. And because you said I'm going to be changing it, is that going to be a writer or a reader or both?
Both.
Both, because I need to read it every now and then, and I also need to write to it when the game finishes. So I'm going to make this an adder accessor with solved. And you said if they guess the correct number, I can change solved to true. Remember, the question mark returns a true or false. It's going to read this particular attribute called solved. At the very beginning, it's always going to be false, and only when you guess the correct number is it going to be true. Let's run the tests. Hopefully something. So we had 7 examples, 1 failure. It's still broken, so let's kind of read. So when a correct guess is made, game guess 10 to change game from false to true. I expected solved, question mark, to have been changed from false to true, but it did not change.
Maybe you need to put the solved equals true in the solved method instead of the else statement.
Yeah.
One more time, I did
I
not get
think
that.
it was asking if, I think it's changing to solved equals true, but it's complaining that it's not being done in the actual solved method, right? Would that be it?
Let's see, how many which line is this test failing on? It's failing on line 34 over here. It changes solved when a correct guess is made. Expect change solved. Oh, you mean
Yeah. Oh, no, I meant like that solved equals true would go in solved question mark method.
Yeah, so you call the function up there.
all right? Someone tell me exactly what lines because I'm not seeing
So
this.
line 16.
Yep.
We want to get rid of that. Actually, we just want to move that down to line 22 instead. I think that's what they're saying.
Like this?
Yes, and then get rid of the question mark, I believe.
Wait, you'll still need to call the function up there in line 16.
Like that?
Yeah.
See it? Still broken.
So if user guessed, so we need to, so actually in line inside of the solve method, I think we should, I think, okay, so get rid of line 16.
Get rid of line 16.
And then really we would need to write in the fact that, well, okay, so in the solve method, we would call guess inside of there, and if it returns, if that returns true, or I'm sorry,
Is
that
missing the
returns-
instance add from solved doing anything? Because it's just saying solved equals true.
Let's find out. That's a great question. So let's go back to the way it was before. Solved equals true. Nine examples, one failure. That was it. So that's kind of interesting. How did you get to that particular
I
point?
think I wrote it. I ran into that problem before with it requiring you to put the instance adds.
Yep. So when you call, when you do an adder writer or an adder accessor, you can call it outside of the function, outside of the class. So if I had like G equals guessing game or something, dot new with 10, I can actually do G dot solved equals true on the outside of it. That's what I mean by an adder reader. I can write it to the outside, but if I'm changing it within the class, I do need that at in the front. It's one of those stupid things that we all just unfortunately need to memorize.
So you said if you're changing it outside.
If you're changing it outside of the class, you can just change it directly.
Right.
If you change it within the class, you need to talk about because it's this particular instance. Yeah. All right, so we have 9 examples, 1 failure. I expected solve to change from true to false, but did not change. It's still the same thing. I'm not sure what's going on here. We grab another person's answer real quick, just so we're not busting our heads on this. All right, so I'm gonna do a few things. Adder accessor, last guess. I think we have most of the things. We're just missing a few. Actually, let's just go back. We were close enough. Uh, 12 examples, 1 failure. So it's only one thing that's broken. And that's this line over here. This expect solve to have changed from true to false, but it did not change. On line 45. So it reflects the last guess. So we need this concept of the last guess that somebody had. Maybe I'll set at last guess equal to nil to start with. I know I'm going to be reading and writing to it, so I'll make that an accessor. We'll just say at last guess equals user guess. We'll change all of this real quick. All right, I'm not gonna beat our heads over this because it's just like one small thing. And the main point of this morning was basically how to write test-driven development. So I'm just gonna review that real quick. TDD stands for test-driven development. Everything that you would want, every single interview that you go to, the answer is yes, I do test-driven development 100% of the time. Test-driven development is really just a way to avoid having a bunch of those like true-false statements and to make sure that your code works. By writing it in this describe and the if blocks here, and again, this just kind of takes practice, these if blocks are for you to read as humans. The code's gonna run either way. It doesn't need you, it doesn't need your human readable code. This is just for you to know exactly what broke at exactly which point. So I describe every single method that I write. I write a little message for me, like it does what I expect to do. So like it returns buzz when it's divisible by 5. Like it's something that I can easily read. And then finally you have this expect line. It goes expect some code that you're going to be executing to equal or to match or to do something. For us, it was to equal, like expect fizz buzz at the 3rd thing to be like to equal fizz. At the 5th thing, it was supposed to equal buzz. At the 15th thing, it was supposed to be fizz buzz. Any questions I can answer off the bat? No. We have a few challenges for today. It is Thursday, so it's going to be a pairing optional day. If you want to pair, feel free to do so. If not, you can work on your own. How did people enjoy regular expressions yesterday?
Good times.
What's that?
Good times.
Good times.
This is sarcasm, right?
It's kind of frustrating, but it's also like you don't really need any skill to do it. It's just kind of like, can you pattern match effectively? So we have Armstrong numbers, most frequent integer, and shuffle. It's only going to be in Ruby today, so we're using R-Spec to test, and we're going to do TDD the entire way. If you want a review for tomorrow, that's also fine. If people want me to do a review or object-oriented programming, happy to do it a little later this morning. It's really up to you. But with that, we'll kind of get started on these 3 challenges. We're going to use R-Spec and test-driven development from here on out.